Hello lovely people, in this video I'm going to show something very cool, a Quant Asylum audio analyzer. Before we start this video, I want to give a huge shout out to Matt, the person behind Quant Asylum, because I asked him for this audio analyzer and he just sent me one. So thank you very much, Matt. Really appreciate it. I'm going to be using this, and in this video I'm just going to do kind of quick review, and we're going to check the software as well. I'm going to tell you what this thing actually is. So if you'll be following me, I started to measure amplifiers, DSPs, head units, and basically everything else that I can get my hands on. To measure that, we need some kind of a device. So I used, for now, my old trusty Focusrite Scarlett 2i2, which is like analog inputs and analog outputs. Now the problem with this is that it's kind of clean enough to measure amplifiers, but the main problem is the input and output voltage. So the Focusrite can output only 1 volt if the signal is single-ended, on balance a bit more, and it can take only 1 volt in. In order to go around all of this, I have to increase the gains on the amplifier, and I need a kind of voltage divider to lower the voltage that's going into this thing. Now, very recently, if you saw my previous video, I bought something else. So I bought a DAC, SMSL DAC, that can output 2 volts, so twice as more voltage compared to the Scarlett, and I bought an ADC, which is Cosmos, and this Cosmos can take either 10 volts here, either 43 volts here, so it's much better, and this combination is much cleaner. It's going down to like 117 dB. Now, this thing, I was eyeing it for quite a while. Since I started to measure, I was looking at gear that would be specifically designed to measure amplifiers, distortion, and everything, but it wouldn't be that expensive. Performance, something similar to audio precision, not as good, but to measure amplifiers and DSPs is perfectly good enough. So what is this thing? This is an audio analyzer that is specifically designed to measure amplifiers. So with all these warnings and everything, it does look like a piece of equipment that belongs in a laboratory. So designed and assembled in the USA. It uses a USB cable, and you have all of these notes and warnings. Like, this product may require more current than a USB port can provide. I'm gonna tell you in a second why. So this is an audio analyzer that has its own software, dedicated software, and it has inputs and outputs. So the outputs and inputs, they use a BNC connector, not RCAs, not XLR, BNC, which is like proper lab grade stuff. I'm not used to BNC connectors because the only thing that I have with BNC is the scope. So I had to buy some adapters. Now, question why it doesn't have like RCAs or something more user-friendly. My guess probably is because these BNC connectors are very cheap and they're good. And if you want to make a item within a certain budget, you kind of have to not spend in areas that there's no reason to spend, because these BNC connectors are perfectly fine. And another thing is that I would imagine these things will be used in manufacturing environment where people have scopes and generators and everything, and they already have loads of stuff that uses these BNC connectors, because it is a thing that anybody can buy. If you go to Quant Asylum, their web page, you can buy this and you can buy some other stuff. So this thing cost, at the time of making this video, a $5.99 in the US. They do sell it in Europe as well for, you can see, 800 euros. Obviously, it's going to be more expensive in Europe because shipping, tax, and everything else. But this thing, even if it seems like it costs a lot, what it is, it's actually not that much. For example, all of this that I bought, like ADC, DAC, and stuff, and cables and everything, probably is close to like half the price of this thing. And when you think that you have one unit, like in one chassis, and the most important thing, it uses only one USB cable, and it has much higher functionality than the stuff that is not dedicated to this, because Focusrite is an audio interface. This is a DAC. This is an ADC, and this is a device that's specifically designed to measure amplifiers. Now, why is it so great? The great things about this is that on the output side, it can output up to 8 volts. My biggest issue with measuring with a Focusrite, for example, is just it's only 1 volt. And if you're measuring amplifiers, amplifiers need at least 4 volts to have the gains all the way down. And there's no product on the market, consumer grade product, that can give you 4 volts on single-ended. You can have like 5 volts on XLR, which is a differential output. However, typical car audio amplifiers don't take those differentials. They need a single-ended. So this single-endedly can do 8 volts of output, which is great. Now, input-wise, it can take, it says here, up to 40 volts RMS. So 40 volts RMS for an amplifier, something like 300 watts. If you're measuring typical 4-channel amplifier, even it's loaded down to 2 ohm, it's not going to be more than 300 watts, probably like close to 200, maybe 220, something like that. So this is perfect to measure 4-channel amplifiers and even smaller stuff. If you want to measure something higher, like monoblocks, like up to 1,000, 2,000 watts, then you need to do something else because you need to decrease the signal that's going into these inputs. So now let's talk about software, connecting it and how to use it and how it is. I didn't use it a lot. I just used it for one evening just to test. When you download the software, it looks like this. So this software is proprietary. You cannot use this thing with something like REW because it doesn't have any ASIO drivers. It uses something that makes it work with no drivers, no nothing. You just plug it in and it goes. This program that's used for measuring, it's like 5 megs or something, so basically it doesn't take any space at all. It's very fast, it's very light. And the best thing, you need only one USB cable to connect it to a laptop. So let me show you how to do that. One plug here, the next plug into the laptop, just like that. It flashes some lights. You cannot see. Yeah, it's fine. And then it says here at the bottom, it says connected and ready. Now you see the problem here. Since this thing outputs 8 volts, it needs more current, because power is like current times voltage. So the voltage is set on the USB is 5 volts. So in order to make 8 volts out, you need much more current than a typical device uses. So like these, they use very little current and they give only 1 volt out. So for this, you need a bit more. Even here it says the 403 current can exceed USB capabilities and see manual. So my laptop, I'm lucky enough that my laptop has 3 USB ports. One is on this side and 2 on this. This is a typical USB 2 port, and these on this side is USB 3 quick charge. So it does, these 2 ports can supply much more current than that one. Hence on this one, you can see the voltage is red, which is too low, and current drawn is already 0.8 amps, so close to an amp. So I'm gonna disconnect it from here and connect it on this side. When I do that, you can see straight away voltage is fine, 4.6, and current this, everything is fine, nothing is red. If you have red, it basically you don't have enough current. What you need to use is a powered USB hub that you can plug into the socket, into the wall, and it would give you more current than your actual laptop can supply. And when you saw me just literally plugging everything in, that's it. There's no settings, no nothing, because this software is proprietary. You don't need anything. It comes calibrated from factory, and that's it. The only thing you have to do is just literally plug it into the laptop and nothing else. When using these things, when you go into REW, you have to find ASIO drivers. You have to make sure that those drivers are working. You have to select inputs, outputs. You need to configure everything. That is a pain. But this product is designed for that, and that's exactly what I mean. Plug in and go. No issues there. I still need to get used to all of this because I just played with this for a few hours, so I'm not very familiar with it. But what I can do is I can show you the actual voltage that's coming out of this, just for you to see. So let's turn on this one. I'm gonna connect the multimeter with these things, just like that. So positive, negative. Now it shows 0. I'm gonna press this idle button And when you press the idle button, it enables the generator. The generator is somewhere here. There we go. So generator, I can increase the amplitude and the frequency. And it shows here. So for now, it's 56 hertz at 1 volt RMS. 1 volt RMS. So now I'm going to increase this all the way up where it goes. And it goes up to 8 plus 18 dBV, 7.94 7.95 RMS. That's very, very close to 8 volts. This is exactly what I mean. It's overkill for amplifiers, because for amplifiers, you need only 4 volts. But having 8, it's even better, because some amplifiers do need 8 volts to max out the gain. So one of the Alpines that I've tested, and I believe Zapcos probably even need even more than that. So having 8 volts on tap is great for amplifiers. Now, one issue that I have with this is that since it's kind of a lab grade thing, everything is in these dBV. So volt decibels, which I am not familiar with them at all. And even in the software, when you have this dBV. When you go in here to attenuate the inputs, everything is dBV, 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 and I'm not familiar with these. So this is just another thing that I'll have to get used to. I kind of know now, after spending a few hours, I kind of know what more or less everything is. I know that 0 dBV is 1 volt, and I know that 6 dBV is 2 volts. And then I know that 32 dBV is 40 volts, something like that. So kind of in your head, you'll have to constantly work between dBVs and volts RMS. The only place where you can see actually volts RMS is this place. I wish that the software would be more user-friendly for beginners, for people that work in actual voltages. But I would imagine from engineering perspective, when you're like developing something, probably dBVs make more sense. But for us amateurs, no. What I would want to see is I would want to see volts, or I don't know, something else. So in the software, you can select basically everything else that you can do with these in REW. You can select the sample rate and everything. So this is input. The inputs and outputs are working on relays. So inside there's small little relays, and you cannot adjust like what you have on this one. For example, you have the gain knob. There's no gain knob. This works very similar to this, where you have these switches to attenuate the inputs. So yeah, it's kind of finicky to get used to, but I think when you get used to it, it works perfectly fine. So just to demonstrate how the relays work, these are the inputs that you can change the kind of sensitivities, kind of gain knob on the input side. And if I choose different inputs, you can hear the relays clicking. Let me just show you. See the relay, and it's the same with outputs as well. When you have less output, like below 0 dBV or whatever, it clicks the relay as well. So it has relays inside, and this is the main reason why this thing doesn't have ASIO drivers for example, REW, because REW doesn't have the ability to control those relays. The only way to control those relays is with something proprietary. So that's why you have this program, and that's why you cannot run it on REW. And it does make sense, because when you want a product that is super, super clean, when you design it, you cannot really rely on open ASIO drivers like ASIO for all or something else. However, I saw in the forum there are talks that Matt might make ASIO drivers. I don't know. We will see. So in regards to the performance of this thing, how clean it is and what can it measure, I did check it and I put it up against whatever I have. So it is much, much cleaner than the Focusrite. And this combination of these two are slightly cleaner compared to this. So if I'm gonna run something, and just to show you what it is, first of all, I need to disconnect this one, and I need to connect it on a loop back. There we go. Just a typical loopback setup, nothing really special. You see, I put something here at the bottom. So this is like a shorting thing, 75 ohms. And in the manual, it's recommended if you're going to use the inputs, not differential, but single-ended, you need to kind of short the other input if you're using only one. So this is exactly what I did. I blocked one and I'm using only one. So let me run something and see what it does. I'm just running the device, so basically the inputs are active, but I'm not playing anything. So here you can see the noise, and you can see it's like minus 150, minus 155, all the way there. If you remember, the amplifiers are measuring about minus 120. There is quite a difference between them. If I enable the generator, which gives me something like 1000 hertz, something similar, it doesn't really matter. The floor kind of rises a bit. There's a few harmonics, but the main thing is THD plus noise is 109. So it, depending on a few settings, it can go lower than that. But the main thing is that it's something about minus 110. This combination between these two can give me a bit lower, minus 117. Now, do you need more? The Helix DSP Pro Mark III that I have, that I tested, measures at minus 100. So this measures 10 dB better than the best DSP that I have. So to say that it's good to measure DSPs is perfectly fine. To measure amplifiers is not even a question. And it works super fast. So I'm gonna try to take one measurement if I can. Where is it? Is it here? You have all of these measurements that you can already take. It's kind of everything is made for you. So just select the measurement that you want to do and the program makes it for you. So the easiest one probably is gonna be this one, which is THD versus output level. I'm gonna click on this. Here you have a few different measurements, different specs to choose, but this window looks exactly the same like in REW. If you remember, you choose the frequency, increments, plus minus. So we're gonna do one measurement from minus 20 dBb up to 0. Actually, I'm going to change this up to 1 so we can see when the inputs clip, because I left this, the input sensitivity as 0, and I unticked the function that automatically changes the range. Because if you leave this ticked, basically, it has a lot of stuff built in. So if your input is higher than you initially set, it automatically switches to a higher attenuation, so just not to overload the inputs. But for this, I'm going to run this, and look how fast it is. So it's running there, click. So from 20 to 1, that's 21 measurement. And that's it. This is done. So you can see this, the last measurement that he did, it went into the clipping because I did it on purpose. And you can see it measures way below 100, all the way there. Again, as I mentioned, you can have better numbers with some different settings, but this is just for you to show how it basically works. It gives you this graph. And the most annoying part for me is this graph thing, because it's not as user-friendly as REW, because REW with graphs, with overlaying stuff, with removing stuff, is just amazing. This is basically when you want to do 1 or 2 graphs, maybe 3, you can overlay on top of each other, and then you can save it as the actual picture. But with REW, you hover on something, it kind of gets highlighted. It does have a function where you can show point values. So if you hover over something, it does show you the actual values, like minus 105, because it's very difficult to see here. But for example, me, I would want to see percentage instead of dBs. So, it's just one thing to get used to. And this, the graph thing, it has loads of different functions, but you just need to get used to how it works like. As long as you have the correct connectors, so for example, this one, you need a BNC to RCA, which I have, and then you need something like this to feed your amplifier input. So you connect this one, and these go directly into your amplifier speaker outputs. And that's it. That's the only thing you need. One USB cable, and everything works. It's so fast and clean. Now what I'm planning to do is just to show you the difference between all of these. So it's going to be a comparison video. I'm going to probably take an amplifier or DSP, and I'm going to measure everything with this thing, with a Focusrite, and with these things. And then we're going to see how big of a difference it is. Does one thing measure slightly better than the other? I don't know, it shouldn't, but we will see. If you want to see the internals of this thing, because there's a few people on YouTube that already made videos with taking them apart and basically going through all the circuitry and everything. I'm not going to do that. I don't want to open it up because I don't want to break anything. Because to me, it's like a dream come true to have this thing. It does have another connector here which can do some extra stuff. I didn't go into very much detail what it can do, but just by reading the manual and online, because it can do like loads and loads of things. So there's like the PCB that is cut in half just to separate the power section from the signal and everything. Then you have this, the same graph that I actually made. So for me, it was something similar, not the same, but something similar. It obviously depends on the settings. And then you have like manual and everything, how to measure everything. One thing to know that I found out only yesterday, that with this you can do speaker impedance measurements. So exactly the same like I did with my Focusrite, with like extra things. So for this as well, you just utilize different inputs and outputs. You can do impedance sweeps. Then you can do something very cool, which is rub and buzz. So basically using some other stuff that Quant Asylum sells, you can find out if a speaker buzzes or rattles or rubs, the coil rubs inside. If you cannot hear it, or you might hear something but you're not sure, you can do that, which is very, very cool. And Quant Asylum sells few different products as well. So this is the analyzer. It's 403, so it was out of stock for the past like half a year or something, but it's now back in stock, so you can buy this one. Then you have the load bank, which I already have my made, so I don't really need it. This is kind of an amplified transducer driver, but it's kind of the same chassis, which is very, very cool. Micro DC voltmeter, if you need something like this, but again, this is just for lab grade stuff potentially. And mic preamplifier, so something like a Focusrite. Basically, you can connect a microphone and do acoustical measurements or whatever if you want. So my first impressions of this thing is as follows. You need to get used to the DBVs. Obviously, you need to get used to the actual software, because every software is something new to learn. But as an all-in-one package, even if it seems like it costs a lot, because I was seriously considering to buying it myself, even for like 800 euros, whatever that is. But Matt was super generous and he just sent me one. So again, thank you very much, Matt. I'm going to be using this constantly from now on, and the only thing I need is to learn the software and to make the actual connections that I need for all the measuring. And for the rest of you lovely people, if you want to be serious about measure amplifiers, if you have some money to spare, buy this thing, because just because of the 8-volt output. This is basically the main reason, because to feed amplifiers you need quite a lot. If you want something cheaper, buy something like this, because this Cosmos thing is amazing, but you will be limited to only 2 volts of output. If you want something even cheaper than that as a budget version, get the Focusrite and do your measurements that way. So this is pretty much it. Thank you very much for watching, guys, and I will see you in the next one.